Hi, guys. We're going to move on to the second method of determining a solution for a system of equations. And today we're going to work with the substitution method, which is actually the method we're going to work with and focus on throughout this week. So today our objective is to determine the solution to two equations by using the substitution method. Okay. These are the 4 steps that you're going to be working with. First, you always want to make sure that one of the equations is solved for x or y. So one of them has to be in y equals or x equals, which most likely I'm going to have always one of them in that format for you. Then step 2, you're going to substitute one equation into the second equation. You're going to solve for that variable that you have in the equation. Then you're going to plug the solution for the one variable into one of the original equations to get the value of the second variable. Okay. Again, these are the steps. They probably make no sense right now, but obviously as I'm going along, these are the steps I'm going to focus with. So you can go back and look at these as you're continuing on through the week, completing your assignments. We still have our 3 types of solutions that we can see. Again, one solution, that's when the 2 lines cross or intersect, and that we always write as an ordered pair. Then we will have our no solution, and of course, that's when the lines are parallel. And then we have infinitely many solutions, which the equations are exactly the same. You're going to notice with the substitution method that there's other ways that we can look at the equations and how we solve them algebraically to see if it's no solution or infinitely many solutions. So basically this week with substitution, you're actually completing more algebra with finding the ordered pair. Anytime you're given a set of systems of equations, you can really choose any method to use. You can always choose to graph it, or you can choose to do substitution, or you can choose to do elimination, which is the third method. So again, I'm going to give you equations today that you could jump over to a coordinate graph and graph them as well, and you would get the same solution. But we're going to focus this week on doing the substitution method. Okay, so example 1. So my first step was to always make sure one of them is in y equals format, okay, which, if you notice, hold on, get my pen going. For some reason, it's not working with me. If you notice, the second one is in y equals format. So that's the one that we're going to want to look at. And what you're going to do is, since it's y equals, I am going to substitute in this x plus 2 where the y is. Okay, so I'm going to come out with 3x plus 5. I'm going to do parentheses to show what I'm substituting in, which is x plus 2. Sorry, my stylus is equals 10. So all I did was I replaced this y with the x plus 2. Okay. Now you're just going to start simplifying and cleaning it up. So I'm going to now distribute the 5 to both x and 2. So I bring down my 3x. 5 times x is 5x, and 5 times 2 is 10, equals 10. Again, continue cleaning up. So I notice this 3x and 5x are like terms, so I'm going to combine them on that side. I'm going to get 8x plus 10 equals 10. Well, now I have a 2-step equation. So I'm just going to continue solving. I'm going to subtract 10 to both sides. Now I'm left with 8x equals 0. when I divide by 8, well, 0 divided by 8 would just be 0. Okay, now I have my x value. Okay, now I'm going to go back and use my solution of x equals 0, and I'm going to plug it into one of the original equations to get my y value. Now, looking at this first equation or the second equation, sometimes you're going to find one looks more inviting to go back and plug into. So hopefully you're looking at the second one and thinking, ooh, that looks a lot easier to plug x into. So I'm going to come up here. And now what I'm going to do is I'm going to substitute in, or it's y equals x plus 2. Now I'm going to plug in 0 for x. So y equals 0 plus 2. And 0 plus 2 is 2. Okay, and then finally your last step is just to put it together as an ordered pair. Okay, so x is 0, y is 2. And that's it. Now again, I could have took those original two equations, I could have pulled out a coordinate graph, and I could have graphed the both of them. And the cool thing is that if I was to graph both of these equations, then I would have had 0, 2 at the point of intersection for them. Okay. Example 2. If you notice for this example, they're both y equals. So I always say when they're both y equals, we set them equal. So what I'm literally going to do is I'm going to take this 6x minus 9 and I'm going to plug it in where the y is. So what I'm going to have is 6x minus 9 equals negative 3x. Okay. So all I did was I took that 6x minus 9 and I substituted it in to the first y value. Again, if they're both y equals, we set them equal. Now in this situation, you're going to end up having variables on both sides. So we need to get one of the variables onto the other side. I'm going to choose to move this 6x to the other side. 6x minus 6x cancels out, bringing down negative 9 equals negative 3x and negative 6x. When you combine them together, you get negative 9x. Now to get x by itself, I'm going to divide by negative 9. Negative 9 divided by negative 9 gives me positive 1. Now I'm going to come up here and I'm going to choose to substitute in the 1 into both the top or bottom equation. Honestly, they're both not bad. I'm going to choose the first one because it's an easier equation. So that's the equation I'm using. Now I'm going to substitute in negative 3, and I'm going to replace the x with a 1 because that's what I got down here. So y equals negative 3 times 1, which is negative 3. So again, my solution, my x was 1, and my y is negative 3. So again, that tells me that if I was to pull out a coordinate graph and plot these two equations, they would intersect at 1, negative 3. So both of these so far, we've seen a one solution situation. So 1, negative 3 is the only point that these two equations will intersect at. Okay, example 3. For example 3, again, we have they're both y equals. We set them equal. So I'm literally just going to say negative 2x minus 4 equals 4x plus 2. Because again, they're both y equals. We set them equal. Now what I'm going to do is I'm going to move one of the variables to the other side. I'll just take this. I'm going to add 2x. Negative 2x plus 2x cancels out. I have negative 4 equals 4x plus 2x is 6x plus 2. Now I have a two-step equation. I'm going to subtract 2. Now I have 6x equals negative 4 minus 2 more is negative 6. Now I'm going to divide by 6. Negative 6 divided by 6 is negative 1. Now I'm going to come up here. Again, you could take either equation. I'll just take the top one. Again, it does not matter if you take the top one or the bottom one. Whichever one you choose, you would get the same y value. As long as your math is correct, of course. Y equals negative 2x minus 4. X is negative 1. Negative 2 times negative 1 is positive 2. Then 2 minus 4. Remember, you're taking away more than you have. So you're going to end up in the negatives. Y equals negative 2. So my solution here would be negative 1, negative 2. Okay. 3 more examples to go through. Okay, example 4. So they're both not y equal. So I'm not going to set them both equal to each other. But instead, I have one of them that is in y equals. So what I'm going to do is I'm going to replace the 5x minus 2 where the y is. So if you recall from example 1, I used parentheses. So I'm going to do negative 10x plus 2 parentheses. And I'm going to replace the y with the 5x minus 2 equals negative 4. Okay. So now with this one, I'm going to end up distributing the 2 to both sides, or I'm sorry, both terms inside the parentheses. I'm going to bring down negative 10x. 2 times 5 is plus 10x. And 2 times negative 2 is negative 4 equals negative 4. Now what I'm going to do is on the same side, I'm going to combine like terms. I'm going to combine. Now when I do negative 10x plus 10x, so negative 10 plus 10, well, what I'm going to actually notice is those actually cancel themselves out. So now I'm left with negative 4 equals negative 4. Guess what? It's a special type of solution. So listen up. If your variables end up canceling out and you're left with a true statement, then it's infinitely many solutions. So I'm going to ask myself, is negative 4 equal to negative 4? Is that a true statement? It sure is. So since it's a true statement, then that means this would be infinitely many solutions. Okay, so again, if the variables cancel out and you're left with a true statement, then it's infinitely many solutions. Awesome. Okay. Here we go for example 5. If they're both y equals, we set them equal. So here I go. 3x plus 5 equals 3x minus 4. All right. Variables on both sides. So I'm going to have to move one of the variables to the other side. So I'll take this first 3x and I'm going to subtract it. On the left side, 3x minus 3x cancels out. I'm going to bring down the 5. Oh man, 3x minus 3x on this side. Well, see you later to that side too. And I'm going to bring down my negative 4. Oh man. So my variable canceled out again, but I'm left with 5 equals negative 4. Here we have a special solution. So if the variables cancel out and you're left with not a true statement, so is 5 equal to negative 4? No way. So in this scenario, when the variables cancel out and you're left with not a true statement, then it is no solution. Okay. So again, when the variables cancel out and you're left with not a true statement, then it is no solution. And finally, example 6. Okay, so I just have one of them in y equals format. So I'm going to have to take this and I'm going to substitute it in where the y is. So what I'm going to do is I'm going to do 4x plus 2 parentheses negative 2x plus 4 equals 8. So all I did is I took this negative 2x plus 4 and I replaced the y with that. Now I'm going to distribute, just pick the same color, the 2. Now I'm left with 4x minus 4x plus 8 equals 8. Same side, so I'm going to combine them and I'm going to add them. 4x plus negative 4x. See ya. Now I'm left with 8 equals 8. So my variables canceled out, and I'm left with 8 equals 8. Well, is 8 equals 8 a true statement? Yeah, the same exact number. So since the variables canceled out and I'm left with a true statement, then it goes back to being infinitely many solutions. Okay. Okay. And again, if you were to actually just look at this first equation, and if you were to move it into slope-intercept form, which I could do, try to fit it in up here. I would subtract my 4x Now I'm left with 2y equals negative 4x plus 8. I divide by 2 to every single term. Just come over here now. Y equals, well, negative 4 divided by 2 is negative 2x. And then 8 divided by 2 is 4. So if you notice, if you were to put this first equation in slope-intercept form, you actually get the same equation. And if you recall, and if you watched my videos for graphing, I said more than once that when you're left with the same exact equation, then you're going to have infinitely many solutions because you're going to have the same exact line. Okay. So now that I went over those 6 examples, okay, and hopefully you had it printed out, or at least you took out some paper to write down and follow along. Now you're going to move on to the show off your skills form for today. Okay, and then don't forget to complete your daily check-in as well. Okay, and don't forget to look in on the assignment today to see how the show off your skills will be graded. Okay, it will count for a classwork homework grade. Okay. Good luck. Again, if you need help, you need to ask, and I will be more than happy to help you. Okay. Have a great day, guys.